The global chip shortage, how it happened and what it means. Part 1. The perfect storm, how the chip shortage began. The global chip shortage has become one of the most disruptive economic events of the 21st century, impacting industries ranging from automotive to consumer electronics, healthcare, and even national security. What began as a supply chain hiccup in 2020 has spiraled into a full-blown crisis, exposing vulnerabilities in the globalized economy and raising questions about the sustainability of our reliance on semiconductors. This article, the first in a 4-part episode, explores the origins of the chip shortage, the factors that converge to create this perfect storm, and why it has proven so difficult to resolve. The backbone of modern life. Semiconductors, or chips, are the unsung heroes of the modern world. These tiny silicon wafers power everything from smartphones and laptops to cars, refrigerators, and even advanced military systems. They are the brains behind artificial intelligence, the Internet of Things, IoT, and the burgeoning metaverse. Without chips, the technological advancements of the past 50 years would have been impossible. Yet, despite their ubiquity, semiconductors are often taken for granted. Most consumers don't think about the complex global supply chain that produces these chips, nor do they realize how fragile that supply chain is. The chip shortage has forced the world to confront this reality, revealing just how dependent we are on a handful of companies and countries for this critical technology. The pandemic, the spark that ignited the crisis. The COVID-19 pandemic was the catalyst for the chip shortage, but it was not the sole cause. When the virus began spreading globally in early 2020, governments imposed lockdowns, businesses shuttered, and consumers hunkered down at home. The sudden shift to remote work, online learning, and virtual entertainment created an unprecedented surge in demand for electronics. Laptops, webcams, monitors, and gaming consoles flew off the shelves as people adapted to the new normal. At the same time, automakers, anticipating a prolonged economic downturn, slashed their orders for chips. The automotive industry accounts for about 10% of global chip demand, and its sudden pullback left semiconductor manufacturers scrambling to reallocate production capacity to meet the surging demand for consumer electronics. This decision would come back to haunt automakers. By mid-2020, as economies began to reopen and consumer demand for cars rebounded faster than expected, automakers found themselves at the back of the line for chip orders. Semiconductor manufacturers, already operating at full capacity, were unable to pivot quickly enough to meet the renewed demand. The result was a shortage that forced automakers to idle production lines, delay vehicle shipments, and lose billions in revenue. A fragile and concentrated supply chain. The pandemic exposed the vulnerabilities of a global semiconductor supply chain that had become increasingly concentrated and specialized over the past few decades. Today, the production of chips is divided among a handful of companies and countries, each playing a specific role in the process. The design of advanced chips is dominated by a few firms, including Intel, AMD, and Nvidia, as well as fabless companies like Qualcomm and Apple, which design chips but outsource their manufacturing. The actual production of chips, however, is concentrated in even fewer hands. Taiwan Semiconductor Manufacturing Company, TSMC, and South Korea's Samsung Electronics together account for more than 70% of the global foundry market, with TSMC alone producing nearly 90% of the world's most advanced chips. This concentration of manufacturing capacity in East Asia, particularly in Taiwan, which is a geopolitical flashpoint, has raised concerns about the resilience of the supply chain. A natural disaster, political conflict, or other disruption in the region could have catastrophic consequences for the global economy. Geopolitical tensions and trade wars. The chip shortage has also been exacerbated by geopolitical tensions, particularly between the United States and China. In recent years, the U.S. government has imposed export controls and sanctions on Chinese tech companies, including Huawei and SMIC, Semiconductor Manufacturing International Corporation, in an effort to curb China's technological ambitions and protect national security. These measures have disrupted the flow of chips and chip-making equipment to China, forcing Chinese companies to stockpile inventory and scramble to develop domestic alternatives. At the same time, China's efforts to achieve self-sufficiency in semiconductors have been hampered by technological barriers and a lack of access to advanced manufacturing equipment. The US-China trade war has also created uncertainty for global chipmakers, many of which rely on both countries for revenue and supply chain inputs. The imposition of tariffs and export controls has increased costs and complexity, further straining an already fragile system. Underinvestment in legacy chips. While much of the attention has focused on the shortage of advanced chips used in smartphones and high-performance computing, the crisis has also highlighted a critical shortage of legacy chips, older, less sophisticated semiconductors that are still widely used in automobiles, appliances, and industrial equipment. Many of these chips are produced on older manufacturing lines, which have seen underinvestment in recent years as semiconductor companies have focused on building capacity for cutting-edge technologies. The result is a mismatch between supply and demand, with automakers and other industries that rely on legacy chips bearing the brunt of the shortage. Climate change and natural disasters. Adding to the complexity of the crisis is the impact of climate change and natural disasters on chip production. Semiconductors are manufactured in highly controlled environments that require vast amounts of water and energy, making them vulnerable to disruptions caused by extreme weather events. In 2021, a severe winter storm in Texas forced the shutdown of several chip plants, including a Samsung facility that produces memory chips. Later that year, a drought in Taiwan, home to TSMC's largest manufacturing hub, threatened to disrupt production, as chipmakers rely on large quantities of water to clean silicon wafers. These incidents underscore the fragility of the supply chain and the need for greater resilience in the face of climate-related risks. The human factor. Finally, the chip shortage has been exacerbated by labor shortages and logistical challenges caused by the pandemic. Lockdowns and travel restrictions disrupted the movement of goods and people, creating bottlenecks at ports and airports. At the same time, outbreaks of COVID-19 at chip factories and other critical facilities forced temporary shutdowns, further straining supply. The pandemic also highlighted the human cost of the chip industry's relentless drive for efficiency and cost reduction. Many semiconductor workers are employed in low-wage, high-stress jobs, often in hazardous conditions. The industry's reliance on migrant labor in countries like Malaysia, a key hub for chip packaging and testing, has made it particularly vulnerable to disruptions caused by lockdowns and border closures. Conclusion: a crisis years in the making. The global chip shortage is not the result of a single event, but rather the convergence of multiple factors, some predictable, others unforeseen. The pandemic was the spark, but the tinder had been building for years, as the semiconductor industry became increasingly concentrated, specialized, and vulnerable to disruptions. In the next part of this episode, we will explore the far-reaching consequences of the chip shortage, from its impact on industries and consumers to its implications for national security and global power dynamics. We will also examine the steps being taken to address the crisis and whether they are enough to prevent a similar shortage in the future. Part 2. The ripple effect, how the chip shortage is reshaping industries and economies. In Part 1 of this episode, we explored the origins of the global chip shortage, tracing its roots to the COVID-19 pandemic, geopolitical tensions, and the fragility of the semiconductor supply chain. In this second installment, we delve into the far-reaching consequences of the crisis, examining how it has disrupted industries, reshaped economies, and exposed vulnerabilities in our increasingly digital world. The chip shortage is not just a problem for tech companies, it is a crisis that has touched nearly every aspect of modern life. From the cars we drive to the devices we rely on for work and entertainment, the ripple effects of the shortage have been profound and, in some cases, irreversible. This article will explore how the shortage has impacted key industries, the broader economic implications, and the lessons we can learn from this unprecedented disruption. The automotive industry, ground zero for the crisis. The automotive industry has been one of the hardest hit sectors, earning it the dubious distinction of being ground zero for the chip shortage. Modern vehicles are essentially computers on wheels, relying on hundreds of semiconductors to power everything from engine control units and infotainment systems to advanced driver assistance systems, ADAS. When automakers slashed their chip orders at the onset of the pandemic, they inadvertently ceded their place in the queue to consumer electronics manufacturers. By the time they realized their mistake and tried to ramp up orders, it was too late. Semiconductor foundries, already operating at full capacity, were unable to meet the sudden surge in demand. The consequences have been devastating. Automakers around the world have been forced to idle production lines, delay vehicle launches, and scale back ambitious plans for electric and autonomous vehicles. In 2021 alone, the global automotive industry lost an estimated $210 billion in revenue due to the shortage, with millions of vehicles left unfinished in factory lots. The crisis has also exposed the industry's over-reliance on just-in-time manufacturing, a strategy that prioritizes efficiency over resilience. By keeping inventory levels low and relying on frequent deliveries, automakers were able to reduce costs, but they also left themselves vulnerable to supply chain disruptions. The chip shortage has forced the industry to rethink this approach, with some companies now stockpiling critical components and forging closer ties with chip suppliers. Consumer electronics, a double-edged sword. While the chip shortage has been a disaster for automakers, it has been a mixed blessing for the consumer electronics industry. On one hand, the surge in demand for laptops, tablets, and other devices during the pandemic has been a boon for companies like Apple, Samsung, and Dell. On the other hand, the shortage has made it difficult for these companies to meet demand, leading to product delays, higher prices, and frustrated customers. The shortage has also highlighted the growing divide between companies that design their own chips and those that rely on off-the-shelf components. Apple, for example, has been relatively insulated from the crisis thanks to its custom-designed chips and close relationship with TSMC. Other companies, particularly smaller players, have struggled to secure the chips they need, putting them at a competitive disadvantage. The gaming industry has been particularly hard hit, with Sony and Microsoft struggling to meet demand for their PlayStation 5 and Xbox Series X consoles. Scalpers and resellers have taken advantage of the scarcity, driving up prices and making it even harder for consumers to get their hands on the latest hardware. Healthcare, a matter of life and death. The chip shortage has also had serious implications for the healthcare industry, where semiconductors are used in everything from MRI machines and ventilators to pacemakers and insulin pumps. While the impact has been less visible than in the automotive or consumer electronics sectors, it is no less significant. Hospitals and medical device manufacturers have faced delays in receiving critical equipment, forcing them to postpone procedures and ration resources. In some cases, the shortage has even put lives at risk. For example, a lack of chips has slowed the production of defibrillators, which are used to treat cardiac arrest. The crisis has underscored the importance of ensuring a stable supply of semiconductors for medical applications. It has also raised questions about whether the healthcare industry should be given priority access to chips during times of shortage, a controversial proposition that pits public health against economic interests. National security, a wake-up call. The chip shortage has also had significant implications for national security, particularly in the United States. Semiconductors are critical to the development of advanced weapon systems, surveillance technology, and communication networks. A prolonged shortage could undermine military readiness and give rival nations like China a strategic advantage. The crisis has prompted the U.S. government to take action, with President Biden signing an executive order in February 2021 to review the resilience of critical supply chains, including semiconductors. The administration has also pushed for legislation to boost domestic chip production, including the Chips for America Act, which provides funding for semiconductor research and manufacturing. However, some experts argue that these measures are too little, too late. The US once dominated the global semiconductor industry, but its share of global chip production has fallen from 37% in 1990 to just 12% today. Rebuilding domestic capacity will take years, if not decades, and will require significant investment from both the public and private sectors. The broader economic impact. Beyond its impact on specific industries, the chip shortage has had broader economic implications, contributing to inflation, slowing economic growth, and exacerbating inequality. The shortage has driven up the cost of everything from cars to smartphones, as companies pass on higher input costs to consumers. This has contributed to rising inflation, which has become a major concern for policymakers around the world. In the US, for example, the Consumer Price Index, CPI, rose by 7% in 2021, the highest rate in nearly 40 years. The shortage has also slowed economic growth, particularly in countries that rely heavily on manufacturing. In Germany, for example, the automotive industry accounts for a significant portion of GDP, and the chip shortage has been a major drag on the economy. Finally, the crisis has exacerbated inequality, both within and between countries. Wealthier consumers and companies have been better able to absorb higher prices and secure scarce chips, while poorer ones have been left behind. This has widened the digital divide, making it harder for low-income individuals and developing countries to access the technology they need to participate in the global economy. Lessons learned. The chip shortage has been a wake-up call for governments, businesses, and consumers alike. It has exposed the vulnerabilities of a globalized economy that prioritizes efficiency over resilience, and it has highlighted the need for greater investment in critical technologies. One of the key lessons of the crisis is the importance of diversification. Companies and countries that rely too heavily on a single supplier or region are vulnerable to disruptions, whether caused by a pandemic, a natural disaster, or geopolitical tensions. Diversifying supply chains, investing in domestic production, and building strategic stockpiles can help mitigate these risks. Another lesson is the need for greater collaboration between governments and the private sector. The chip shortage is a global problem that requires a global solution, and no single country or company can solve it alone. Governments must work together to address the root causes of the crisis, from underinvestment in legacy chips to the concentration of manufacturing capacity in East Asia. Finally, the crisis has underscored the importance of innovation. The semiconductor industry is constantly evolving, and companies that fail to keep up risk being left behind. Investing in research and development, exploring new materials and manufacturing techniques, and fostering a skilled workforce are all critical to ensuring the long-term resilience of the industry. Conclusion: a crisis with far-reaching consequences. The global chip shortage is not just a supply chain problem, it is a crisis with far-reaching consequences for industries, economies, and societies around the world. It has exposed the vulnerabilities of our increasingly digital world and forced us to confront the challenges of building a more resilient and sustainable future. In the next part of this episode, we will explore the geopolitical dimensions of the chip shortage, examining how it has reshaped the global balance of power and intensified the rivalry between the United States and China. We will also look at the role of Taiwan, the world's most important chip maker, and the risks posed by its precarious geopolitical position. Part 3: The Geopolitics of Chips, How the Shortage is Reshaping Global Power Dynamics. In the first two parts of this episode, we explored the origins of the global chip shortage and its far-reaching consequences for industries and economies. In this third installment, we turn our attention to the geopolitical dimensions of the crisis, examining how it has reshaped the global balance of power and intensified the rivalry between the United States and China. Semiconductors are not just a critical component of modern technology, they are also a key battleground in the struggle for global dominance. The chip shortage has exposed the vulnerabilities of a globalized supply chain that is heavily dependent on a handful of countries, particularly Taiwan. It has also highlighted the risks of relying on a technology that is increasingly central to national security, economic competitiveness, and geopolitical influence. This article will explore the geopolitical implications of the chip shortage, from the growing tensions between the US and China to the precarious position of Taiwan and the efforts by other countries to secure their own chip supply chains. It will also examine the role of industrial policy, export controls, and international alliances in shaping the future of the semiconductor industry. The US-China Tech War. The chip shortage has intensified the ongoing tech war between the United States and China, two superpowers vying for dominance in the semiconductor industry. For decades, the US has been the global leader in chip design and innovation, while China has focused on manufacturing and assembly. However, China's ambitions to achieve self-sufficiency in semiconductors have raised concerns in Washington, prompting a series of measures aimed at curbing Beijing's technological rise. In 2019, the Trump administration blacklisted Huawei, China's leading tech company, effectively cutting it off from US technology and software. The Biden administration has continued this hardline approach, imposing export controls on advanced chip-making equipment and restricting Chinese companies' access to cutting-edge semiconductors. These measures have forced Chinese firms to stockpile chips and accelerate efforts to develop domestic alternatives, but progress has been slow due to technological barriers and a lack of expertise. The US-China tech war has created a fragmented global semiconductor market, with each country pursuing its own industrial policies and supply chain strategies. This fragmentation has increased costs and complexity for chipmakers, many of which rely on both countries for revenue and supply chain inputs. It has also raised the risk of a decoupling of the US and Chinese economies, with potentially far-reaching consequences for global trade and innovation. Taiwan, the linchpin of the global chip industry. At the heart of the chip shortage is Taiwan, a small island nation that produces more than 60% of the world's semiconductors and over 90% of the most advanced chips. Taiwan Semiconductor Manufacturing Company, TSMC, the world's largest chip foundry, is a critical player in the global supply chain, supplying chips to companies like Apple, Nvidia, and Qualcomm. Taiwan's dominance in the semiconductor industry has made it a focal point of geopolitical tensions, particularly between the US and China. China views Taiwan as a breakaway province and has not ruled out the use of force to achieve reunification. The US, meanwhile, has pledged to defend Taiwan against any aggression, raising the specter of a military conflict that could disrupt the global chip supply chain. The chip shortage has underscored the risks of relying so heavily on Taiwan for semiconductors. A natural disaster, political instability, or military conflict in the region could have catastrophic consequences for the global economy. This has prompted calls for greater diversification of the semiconductor supply chain, with countries and companies seeking to reduce their dependence on Taiwan by investing in domestic production and forging partnerships with other chipmakers. The race for chip sovereignty. The chip shortage has sparked a global race for chip sovereignty, as countries seek to secure their own supply chains and reduce their reliance on foreign suppliers. The US, China, and the European Union have all announced ambitious plans to boost domestic chip production, with billions of dollars in subsidies and incentives on offer. In the US, the Chips for America Act provides $52 billion in funding for semiconductor research and manufacturing, with the goal of reducing reliance on foreign suppliers and strengthening national security. The Biden administration has also sought to rally allies to counter China's growing influence in the semiconductor industry, forming partnerships with countries like Japan, South Korea, and Taiwan. China, meanwhile, has launched its own efforts to achieve self-sufficiency in semiconductors, investing heavily in domestic chipmakers and research institutions. However, progress has been hampered by technological barriers, a lack of expertise, and US export controls. Despite these challenges, China remains determined to build a world-class semiconductor industry, viewing it as essential to its economic and military ambitions. The European Union has also entered the fray, unveiling a €43 billion plan to boost chip production and double its share of the global semiconductor market by 2030. The EU strategy focuses on building a chip ecosystem that includes research, design, and manufacturing, with an emphasis on collaboration between member states and industry stakeholders. The role of industrial policy. The chip shortage has reignited the debate over industrial policy, with governments around the world adopting a more interventionist approach to the semiconductor industry. Critics argue that subsidies and protectionist measures distort markets and stifle competition, while proponents contend that they are necessary to address market failures and ensure national security. The US and China have taken very different approaches to industrial policy, reflecting their contrasting economic systems and political ideologies. The US has focused on fostering innovation and competition, with an emphasis on public-private partnerships and targeted investments in research and development. China, by contrast, has pursued a state-led model, with the government playing a central role in directing resources and setting strategic priorities. The effectiveness of these approaches remains to be seen, but one thing is clear: the chip shortage has forced governments to rethink their role in the semiconductor industry and take a more active stance in shaping its future. The risks of fragmentation. While the push for chip sovereignty may reduce dependence on foreign suppliers, it also carries risks. A fragmented global semiconductor market could lead to inefficiencies, duplication of efforts, and higher costs for consumers. It could also undermine the collaborative nature of the industry, which has historically relied on global supply chains and international partnerships to drive innovation. Moreover, the pursuit of chip sovereignty could exacerbate geopolitical tensions, particularly between the US and China. As countries compete for dominance in the semiconductor industry, they may resort to protectionist measures, export controls, and other forms of economic warfare, further destabilizing the global economy. Conclusion: a new era of geopolitical competition. The global chip shortage has ushered in a new era of geopolitical competition, with semiconductors emerging as a key battleground in the struggle for global dominance. The crisis has exposed the vulnerabilities of a globalized supply chain and highlighted the risks of relying on a technology that is increasingly central to national security, economic competitiveness, and geopolitical influence. In the final part of this episode, we will explore the future of the semiconductor industry, examining the steps being taken to address the chip shortage and the challenges that lie ahead. We will also consider the broader implications of the crisis for the global economy, technological innovation, and the balance of power in the 21st century. Part 4: The road ahead. Can the world fix the chip shortage? In the first 3 parts of this episode, we explored the origins of the global chip shortage, its far-reaching consequences for industries and economies, and its geopolitical implications. In this final installment, we turn our attention to the future, examining the steps being taken to address the crisis and the challenges that lie ahead. The chip shortage has exposed the vulnerabilities of a globalized supply chain and highlighted the need for greater resilience, innovation, and collaboration. While the crisis has prompted governments, companies, and industry stakeholders to take action, the road to recovery is long and fraught with challenges. This article will explore the efforts underway to address the shortage, the obstacles that must be overcome, and the broader implications for the global economy and technological innovation. Building resilience, diversifying the supply chain. One of the key lessons of the chip shortage is the importance of diversification. Relying too heavily on a single supplier, region, or technology can leave companies and countries vulnerable to disruptions. To build greater resilience, governments and companies are taking steps to diversify their supply chains, invest in domestic production, and forge new partnerships. In the United States, the CHIPS for America Act provides $52 billion in funding for semiconductor research and manufacturing, with the goal of reducing reliance on foreign suppliers and strengthening national security. The Biden administration has also sought to rally allies to counter China's growing influence in the semiconductor industry, forming partnerships with countries like Japan, South Korea, and Taiwan. Similarly, the European Union has unveiled a €43 billion plan to boost chip production and double its share of the global semiconductor market by 2030. The EU strategy focuses on building a chip ecosystem that includes research, design, and manufacturing, with an emphasis on collaboration between member states and industry stakeholders. Even China, despite facing significant technological barriers, has launched its own efforts to achieve self-sufficiency in semiconductors, investing heavily in domestic chipmakers and research institutions. Investing in innovation, the next generation of chips. While diversifying the supply chain is critical, it is not enough on its own. The semiconductor industry is constantly evolving, and staying ahead of the curve requires continuous investment in research and development. One area of focus is the development of new materials and manufacturing techniques. Silicon has been the backbone of the semiconductor industry for decades, but it is reaching its physical limits. Researchers are exploring alternatives like gallium nitride, GaN, and silicon carbide, SiC, which offer higher performance and energy efficiency. Another promising area is the development of 3D chip architectures, which stack multiple layers of transistors to increase performance and reduce power consumption. Companies like Intel and TSMC are already investing heavily in this technology, which could revolutionize the industry. Finally, there is growing interest in quantum computing, which promises to solve complex problems that are beyond the reach of classical computers. While still in its early stages, quantum computing could eventually disrupt the semiconductor industry and create new opportunities for innovation. Addressing the talent shortage. The chip shortage has also highlighted a critical shortage of skilled workers in the semiconductor industry. Designing and manufacturing chips requires a highly specialized workforce, but many countries are facing a talent crunch due to aging populations, declining interest in STEM fields, and competition from other industries. To address this challenge, governments and companies are investing in education and training programs to develop the next generation of semiconductor engineers and technicians. For example, the U.S. National Science Foundation has launched a $200 million initiative to expand semiconductor education and workforce development, while companies like Intel and TSMC are partnering with universities to create specialized training programs. However, addressing the talent shortage will require more than just training programs. It will also require efforts to make the semiconductor industry more attractive to young people, including competitive salaries, career advancement opportunities, and a commitment to diversity and inclusion. The role of governments and industry stakeholders. The chip shortage has underscored the need for greater collaboration between governments and industry stakeholders. No single country or company can solve the crisis alone, and addressing the root causes of the shortage will require a coordinated global effort. One area where collaboration is critical is in the development of industry standards. The semiconductor industry is highly fragmented, with different companies and countries using different technologies and processes. Developing common standards could help reduce costs, improve efficiency, and foster innovation. Another area where collaboration is needed is in the regulation of the semiconductor industry. Governments must strike a balance between promoting competition and ensuring national security, while also addressing issues like intellectual property rights, export controls, and environmental sustainability. The broader implications for the global economy. The chip shortage has far-reaching implications for the global economy, from inflation and supply chain disruptions to the digital divide and technological innovation. One of the most immediate consequences of the shortage has been rising inflation, as companies pass on higher input costs to consumers. This has put pressure on central banks to raise interest rates, which could slow economic growth and increase the risk of a recession. The shortage has also highlighted the growing digital divide between countries and communities that have access to advanced technology and those that do not. As the world becomes increasingly digital, ensuring equitable access to semiconductors and other critical technologies will be essential to reducing inequality and promoting inclusive growth. Finally, the chip shortage has underscored the importance of technological innovation in driving economic growth and competitiveness. Countries that invest in research and development, foster a skilled workforce, and create a supportive regulatory environment will be better positioned to thrive in the 21st century. Conclusion: a call to action. The global chip shortage is a wake-up call for governments, companies, and industry stakeholders. It has exposed the vulnerabilities of a globalized supply chain and highlighted the need for greater resilience, innovation, and collaboration. While the road ahead is challenging, it is also full of opportunities. By investing in diversification, innovation, and talent development, the world can build a more resilient and sustainable semiconductor industry that is capable of meeting the demands of the 21st century. The chip shortage is not just a crisis, it is a call to action. It is a reminder that the technologies we rely on are not invincible, and that we must work together to ensure their continued availability and accessibility. The future of the global economy, technological innovation, and geopolitical stability depends on it.